know. So let's continue our lecture. We're just left with one formula, how to use double integral to calculate the surface area. Well, let us take a look at the formula that we have. The area of the surface, the area of the surface of, suppose you have a surface defined by function z equals to f of x and y, and we're interested in finding the area of that surface. With domain V, remember that we're dealing with the domain, the collection of points, ordered pairs, that the function is defined on those ordered pairs. Then the surface area is defined as area of the surface is equal to. Well, we're going to use double integral to define the area of the surface in 3 dimensions. It's equal to double integral. Then we're going to have the square root 1 plus, we're going to deal with the partial derivatives. The partial derivative of f with respect to x squared plus the partial derivative of f with respect to y squared dA over your region. Remember that in elementary calculus, if we have a curve y equals to f of x, we can measure the length of the curve using integral. Then the length of the curve, suppose this guy has the curve as visualization, y equals to f of x, and you're interested to know what is the length of this curve. Of course, we're not going to continue this curve from both sides. It's going to go to infinity. So suppose it's bounded between a and b. And then you're interested in finding the length of this curve. Suppose just this piece, this length. This is what we learned before. This guy is defined as L equals to the integral a to b square root of 1 plus the derivative raised to the second power dx. So we can generalize this formula and actually use the area of a surface using double integral. Let's go over one quick example. In this example, what do we have? We have the surface. The surface is defined as z equals to x squared plus 2y. And then it says, find the area of this surface above. We're going to restrict the surface from below by a region. What is our region? Surface above a triangular region, which is bounded by these vertices, 0, 0, comma, 1, 0, 1 and 1, 1, 0, and 1 and 1. Okay, perfect. So remember that when it comes to applying double integral, we are always interested in knowing what that region looks like. Why is that? it helps us to find the boundaries. So step one, graph the region. Okay, it's not very hard to graph this guy here. What do we have? We have x-axis, we have y-axis. We're looking at the region in 2 dimensions, in xy plane. Think about a building. You have the base of the building, and on top, you have the ceiling of the building. Not all buildings are like this. Not all buildings are symmetric. This is the base of the building, and then 3D, not 2D. This is the base of the building, for example, and then on top, you have, sometimes you get a symmetric ceiling. Well, some other times you don't have a symmetric ceiling. You might have the base like this, but the ceiling might be slant. Or it might be even curved, who knows? So the ceiling is different, but as long as we know information about the base, then we can use the double integral to find the height, which is between the base and the height. So here you have 0 and 0. This guy is just right here, 1 and 0. 1 and 0. And then you have 1 and 1. 1 and 1. This is my base. This is the base of the building. I know it's not a regular base, but think about it as a base of just, you know, some patio or some part of the building. This is the base. But what is the boundaries for this base? You might say, hey, I want to fix x, since it's easier for me. X is bounded between 0 and 1. Yeah, why not? X is bounded between 0 and 1. But my y is changing between 0 and this top line. As I walk from left to right, my y increases. And these line segments get different measurements. So my y is changing between this line, which is 0, to this line, which is an increasing line. But what is the equation of this line? So 0, 0, 1, 1, y equals to x. So my y is bounded between 0 and x. This is one way to set up the boundary. You might say, hey, I want to fix my y. You might say that, hey, let me use a different color, or if you want to set it up this way, or you might say that, hey, my y is bounded between 0 and 1, then I'm going to squeeze my x from left and right. So if you set your y between 2 fixed numbers, 0 and 1, then your x is bounded between, from left, your x is bounded between y, and from right, it's bounded between this vertical line, which is 1. Both of these give you the exact same answer. It doesn't matter which one you use. So we're interested in finding the surface area of this ceiling, over this base. This is your ceiling, and this is your base. And visualize it this way, for example. So here I have this base down here. Then on top, I have whatever it is. And then I'm finding, let's see, here, just change these this way. We're interested in finding the area of the surface here. The area of the surface. This is the area of this portion of the surface. Very well. They have a formula to follow. The surface area is equal to integral, the double integral, square root of 1 plus, taking the derivative with respect to x, 2x, plus taking the derivative with respect to y, 2 squared dA. Well, this is totally up to you to use the first boundaries or the second boundaries. It doesn't matter. Sometimes you have a complicated function, and if you use one set of boundary, you make it more complicated. For example, you cannot calculate the inner integral. You have to switch to the second sets. Let us try to see if I plug 0 and 1 for x, and for y, 0 and x, what do I get? Wow, take a look at this. This is 0 to 1, and here I have 0 to x, square root of 1 plus 4, 5, 5 plus 4x squared dy dx. So I'm going to take the integral with respect to y first. This guy doesn't have any y. It means that this is just a constant. So what I get integral 0 to 1 square root of 5 plus 4x squared. And here the integral of y is just, the integral of dy is just 5. The integral of dy is just y. So this guy is going to be x minus 0 dx. Very well. Now it makes life much more easier for me. Why is that? Because I can use the substitution method to calculate this integral. Substitution method, this is going to be your u, and dv is 8x dx. U is 5 plus 4x squared, and du is 8x dx. I don't have 8, but it means that my x dx is du divided by 8. Well, this is equal to integral 0 to 1, and here I have the integral of u and du divided by 8. Well, here again, just ignore these for now, then substitute them later. And another thing that you need to remember is when you have the integral of u to power a half du, this is going to be 1 divided by a half plus 1, u2 a half plus 1. So you're going to get 2/3, u2 3/2. This is what we learned from elementary calculus. So I have 1 over 8, and then I have 2/3. What is my u? U is 5 plus 4x squared, and raised to 3/2, but my x is bounded between 0 and 1. Now we just need to substitute this. After substitution, we're going to get 1/12. And then we have 27 minus 5 square root of. You can use a calculator to get an approximation.